In the previous video, we went over our exponent rules, and I said there that you're going to need them for certain questions on the test, and we looked at a couple of relatively simple examples. But here are some questions involving equations where exponent rules become really, really important. So let's take a look at this one. If 2x plus 3y equals 4, what is the value of 9 to the x times 27 to the y? There's multiple ways to do this. I'm going to show you two ways, but one of the common links between all these methods is this key idea that you need to use your rules to give the exponents the least common bases. In other words, you want to reduce those exponents, those bases, to the point that those bases become the same, because then once they're the same, in this case, they're going to be reduced to a base of 3. Once they're the same, then you can use your exponent rules to combine them and do all good stuff. The first way I want to show you is substitution. So that involves us taking this equation, solving for either x or y, and then substituting it into our expression on the right, and then hopefully getting some numerical answer, because we need a numerical answer. This is a grid in, it's a free response. We can't put in an x or a y. We got to put in a number. So let's solve this. I'm going to solve it for x. You could also solve it for y. Either way is fine. In any event, we get 2x equals 4 minus 3y. So x is equal to 2 minus 3 halves y. And now I'm going to take this and I'm going to plug this in for x in our expression. So I'm going to get 9 to the 2 minus 3 halves y times 27 to the y. And now we get to the key idea. In order to go any further, I need to be able to get these to common bases. And if I think about 9, as we've seen previously, this is just 3 squared. So I'm going to write that as 3 squared to the 3 halves minus y, or 2 minus 3 halves y. 27 is the same thing as 3 cubed. So that's 3 cubed to the y. Now that I have the same bases, or well, before I do that, now what I want to do is use my third exponent rule to combine these, right? If I raise a power to a power, I multiply. So this becomes 3 to the 4 minus 3y times 3 to the 3y. And now that I've got the same bases, which was the whole point of doing this, I can now combine them together. And when I multiply these two exponents together, or these two bases with exponents, I have to add the exponents. So this is going to be 3 to the 4 minus 3y plus 3y. The 3y's cancel, which is great, because I'm just left with 3 to the 4, which is 81. And that's my answer. So that's one way to do it. There's a second way to do it, which is actually much shorter and kind of cooler. So let's actually start with just this, 9 to the x times 27 to the y. And let's first, again, key idea, reduce this to those common bases. So as we saw, this is 3 squared to the x times 3 cubed to the y. And then using our exponent rules, this is the same thing as 3 to the 2x times 3 to the 3y. And now I'm going to combine them together using the first exponent rule. Put that up here. And I get 3 to the 2x plus 3y, because I'm adding my exponents. Now, wait a minute. This looks familiar. 2x plus 3y. It's been defined for us earlier. That's the kind of the whole point of the question. So we can then just substitute this in directly. 2x plus 3y is the same thing as 4. So that's just 3 to the 4, which again is 81. Now, both of those methods, whichever one you prefer, run with it. I think you should try to understand both. But either way, you got to get that idea of getting to that common base. Let's look at another example of a question that does this. So we have I'm just going to mark this as an example. We have if x to the a squared over x to the negative b squared equals x to the 8, x is greater than 1 and ab is 3. What is the value of a plus b squared? So it looks pretty complicated at first, but it's not that bad once we break it down and see what's going on. Because the first thing we should notice is if I've got two exponents here with the same base, so that means when I divide them, I can subtract my exponents. So x to the a squared over x to the negative b squared, that's going to be the same thing as x to the a squared minus negative b squared. Remember to be careful with your sign. We're subtracting negative b squared, so that actually just becomes plus b squared. And I know this is equal to x to the 8, so let's hold that aside for a second. We know ab is 3, fine. And we want to know the value of this. Now, whenever you see a binomial squared like this, what you want to do is FOIL it out. And remember, this is not equal to a squared plus b squared, because there's that middle term that you get when you actually FOIL out a plus b times a plus b. So remember that. So what we're going to do is we're going to FOIL this out. We're going to get a squared plus ab plus ab, so plus 2ab plus b squared. So what do we do now? Well, notice if we go back to this bit, we know that a squared plus b squared is going to have to equal 8. Because if these two sides are going to equal, since the bases are already equal to each other, the exponents are going to have to be equal to each other so that the two sides are equal. So we know that a squared plus b squared equals 8. We know that ab equals 3. Notice if I do a little rearranging of this, just move the b squared over, switch places with the ab, I get a squared plus b squared plus 2ab. Now wait a minute, we know this has been defined earlier. This is 8. And then this was given to us in the problem. ab is 3, so 2 times ab would be 6. So a plus 6 is 14. And there you go. So that's a pretty hard question. That's really probably the hardest type of question you might ever see with exponents. But it's all about those exponent rules, right? You got to be very comfortable using them in both directions, right? In this case, we're dividing exponents, so we subtract them. You might also sometimes have to take an exponent that's, got a subtraction in the exponent and take it apart into dividing of two exponents, right? Going in both directions is important. But once you know those rules, once you're comfortable with them, these questions become pretty straightforward.